In this part of the video, I'm going to show you how the UID changing program works. We have seen this program in the last part. In order to change the UID, we are going to use the example program called Change UID. So the UID you want to change, you're going to define in this hash defined constant. And this is just a standard program, just like you write any other Arduino program. You first initialize the SPI and you have to initialize this MFRC522 library, and this is the default key of this classic tags. The default key is all 6 bytes set to FF, and the actual program starts from here. These 3 lines of programming first detects the tag, and this section prints the existing UID of the tag, and all the magic happens here. So in order to change the UID, so there is a function called MFRC522 where we pass the new ID and the size of the UID. In MFI tags, the size of the UID is 4 bytes. So after this changing the UID, the remaining lines here, this line is going to halt and reselect the tag again, and finally this line is going to dump the content of the UID. So what we have to do now is check how this program is written, or understand what is inside this the program called MFRC522. So in order to do that, you have to go and open the source code of this library, so which I'm going to do next. So in the last video I showed you, this is the place where I have copied the library. If you open that and open this, looks like it's the name of the author, and inside here you got these 2 files, the MFRC522.h, that's a header file, and this is the C++ file. So I'm going to open this MFRC522.cpp or the C++ program in the text pad, and this is the program. So you can search for the string called the MFRC522, and this is the name of the function. And what you can see here is the very first thing is the basic validation, which is very straightforward here. This checks that the UID, these variables, the new ID, the bytes or UID size, they got some values set. So the first step in this function is to authenticate with the sector 0. You know that in any MFI tags you cannot write without authentication, and in order to change the UID we have to write to the block 0. So before you write or change block 0, you have to first authenticate with the default password, so all FFs. So in fact we are using the key A to authenticate. In MFI Classic you got key A as well as the key B, and this step is just that, it's trying to authenticate the sector 0, and this is all the basic validation, whether the authentication is successful or not. And if it's not successful first time, it try to authenticate again. So there is nothing very major things are happening here. And the second step is, so this is something, it's very crucial here. So we are going to read, this is going to read the content of the block 0. So looks like this program is going to keep everything except the UID, and one more thing called as the BC, this is also called a checksum. So as you can see here, we are going to read the content of block 0, and this is just a basic validation that checks whether the read is successful or not. So after that, we are going to replace the first 4 bytes of the block 0. That's where the UID is stored, and this loop here that loops from 0 to the size, it could be 0 to 4. So this is where we are going to replace with the new UID. At the same time, it's also calculating the checksum, which is nothing but the XOR of the UID bytes, the 4 bytes. And after that, the checksum is stored in the byte or in the offset 4, that is soon after the UIDs are stored. The next byte is the BCC byte, and it's just the first 5 bytes are replaced, whereas all the remaining bytes that are read in the block 0, they are just retained as it is. And the next step here is something to do with stopping the cryptographic encryption, so probably we have to do that. And next, there's a function, there's a call to a function called open UID backdoor. So there's something magic happening, or some magic has to be done before the actual write takes place. So if you just assume this as there's something magic is happening there, the last step will be to write to the block 0. So looks like just before something is returned to the block 0, so some magic has to be done, and you're going to see now what exactly is this function. If you go scroll up a little bit, there is a function called open the MFARE open UID backdoor. There's a nice documentation here. So it says perform some magic sequence needed to get the Chinese UID changeable MFARE tags to allow to write sector 0. Looks like in order to write to sector 0 and block 0, you have to do this magic. So keep in mind, it's not possible to write in a normal card. You can't write anything to block 0. And there are some nice documentation also speaks about the brick cards. So what this function does is, so it is trying to send the command 40 to the tag. Before that, it's halting, it's bringing the tag to the halt condition. So after that, it's going to send the command 40, and all these things they're pretty straightforward. So from here to here, so it's all about sending the command 40. Looks like this command 40 is understood only by these Chinese UID changeable tags. This command is not understood by a normal tag. And after this command is sent to the tag, so here there is a check made for the response. Looks like the card is going to respond with only 1 byte with the value as 0A. So this is just a basic validation. So if you assume that the value of this the response you got after this command 40, if it's a 0A, so it goes to the second step here. The second step, the command 43 is passed to the tag, and here also the response expected is 0A, and if the response is 0A, the tag probably the tag is opened for writing to block 0, and that's all it does. That's all this function called open UID backdoor does. So after that, when the backdoor is open, and when the backdoor is open here, and this command is what we already initialized before, where the first 4 bytes is UID, the 5th byte is the BCC, and everything returned to the block 0. So this is just bringing the tag or waking the tag up, and if everything is fine, the function returns true. and you're back into this this example program. We just go and have a look at that. So if this function returns true, so you see this message. So after that, the function, the card is sent to the halt state, and it is reactivated, and just the thing, the memory dump is done. So after looking at this code, it looks like the most important thing that is happening here is sending this magic commands. That's the command 40 and followed by the command 43, and in both these commands the response will be 0A. So looks like this is what it's called as a backdoor commands.